Hello, dear students. You're welcome to RK Institute. I am Dr. RK Seni, and today I am going to discuss elimination reactions. It is the topic of reaction mechanism under GOC, and particularly I am going to discuss alpha elimination or 1-1 elimination. First, some brief introduction about elimination reactions. Elimination reactions are those reactions in which molecule or group or atoms removed from the substrate. For example, in case of alcohol, heated in presence of acid catalyst, then they eliminate water molecule and change into alkene. Like as this. When alkyl halide treated with alcoholic KOH or in presence of base, then they eliminate HX and also change into hydrocarbon. These are the elimination reactions. Water eliminate from alcohol, HX eliminate from alkyl halide. Similarly, when beta keto acid under pyrolysis means heating, then they eliminate CO2. And these are the known as elimination reactions. Means some molecules or eliminators are eliminated from the substrate. Then these reactions are known as elimination. On the basis of the position of eliminators or group, elimination reactions are known as alpha elimination, particularly, or old name is 1-1 elimination, or also known as alpha elimination. Second, alpha beta elimination, old name is 1-2 elimination, or now these are now commonly known as beta elimination. Second, gamma elimination or 1-3 or higher elimination. Means when eliminator eliminate from same carbon atom, or group eliminate from one carbon atom, then these are known as alpha elimination. For example, when chloroform treated with strong base like as alcoholic KOH, then chloroform treated with strong base like as alcoholic KOH, then it change into dichlorocarbene. First, elimination of H plus ion means deprotonation takes place. And carbon carry negative charge, and it contains 3 more stronger minus I effect group, and due to positive charge the size of carbon atom is increased, and as it eliminate Cl further in form of anion. Therefore now it change into dichlorocarbene. This dichlorocarbene contain empty orbital as well as one lone pair of electron, and this type of carbene is known as singlet carbene. Carbene are also two types, singlet and triplet. This carbene is singlet, and the eliminator H and Cr eliminate from same carbon atom, and as it is known as alpha elimination or 1-1 elimination. For example, take another example. When dichloromethane is strongly heated or treated with ultraviolet radiation, then it eliminate N2 molecule and change into, this is the gas, and this change into dichlorocarbene also. In this dichlorocarbene, the carbene is triplet type. For example, the dichlorocarbene in gaseous state as following structure. In gaseous form, dichlorocarbene as following structure. Homoletical fission takes place at high temperature or ultraviolet radiation. At high temperature or UV radiation, homolytic fission takes place. Therefore, N2 gas removed from the dichlorocarbene, or we can say N2 gas released from the same carbon atom, and as it is also known as alpha or 1-1 elimination or simple alpha elimination, because both nitrogens eliminators, atom of eliminator eliminate from same carbon atom, then it is also known as elimination, alpha elimination. In this case, two unpaired electron are separately present at the different orbitals. Two unpaired electrons separately present at the different orbital, and it is known as triplet. Carbene. These carbenes are highly unstable because octet incomplete. These carbenes are highly unstable because octet incomplete. Only 6 electrons present at the outermost shell of carbon. And due to incomplete octet, they are highly reactive and are not isolated from the reaction mixture. And these carbenes are isolated in form of compound with alkene, like as alkene, or in another reactions. For example, when chloroform treated with form phenol, then it change into salicylaldehyde, etc. For example, when this carbene treated with alkene, for example, this is the cis alkene, cis 2-butene, and the carbene, particularly dichlorocarbene, particularly singlet carbene. The singlet carbene contain lone pair of electron as well as empty orbital. When due to electrophilic nature of carbene, it's react with alkene. Then delocalization of pi electron simultaneously make a cyclic ring. And hence, it is stereospecific, means when cis alkene react with dichlorocarbene, then product is also cis, cycloalkane, and product is cis. 1,2-dichlorocyclopropane, product cis, because a cyclic transition state is there. When we use trans 2-butene with dichlorocarbene of particularly singlet type, then the product is also cis, then product is also trans, because stereospecific nature of this. And hence, during the reaction, it is electrophilic and cyclic transition state. 3-membered cyclic transition state is there, in which no rearrangement, and then stereoisomers produce same type of stereoisomers in this reaction. If reactant is cis, then product is also cis, cyclopropyl, and when reactant is trans, then product is also trans, in case of singlet. But when triplet carbene react with alkene, then product is non-stereospecific, means both products are there. For example, this is the triplet alkene. It contains unpaired electron in 2 separate orbitals. It means homoletical fission of pi bond takes place. When homoletical fission of pi bond takes place, then free radicals are formed. And this free radical combine with this and make a free radical species, CH2. It also contains empty orbital. Now, formation of same bond as well as rotation of sigma bond along with axis. Therefore, the product is cyclopropane in same configuration. This is trans. The product is also trans, maybe also trans. And when during the rotation of this bond, then CH2 in above, and the product is cis also. This CH3 and this CH3 in same side. The product is cis also. And as triplet carbene are non-stereospecific. This is the elimination, first or even elimination. In another class, in next class, we discuss elimination reactions on the basis of their mechanism, like as E1, E2, E1CB, EI, etc. Okay, bye.